now that we've defined acids and bases and how to identify them, we can see what types of reactions occur when we combine an acid and a base. So these are referred to as neutralization reactions, and we can write an acid plus a base is going to give us a salt plus water. And an example of such a reaction would be nitric acid, which is HNO3, plus calcium hydroxide, which is CaOH2, giving us calcium nitrate, which is CaNO3 twice, plus water. In order to balance this equation, we need a 2 in front of the nitric acid and a 2 in front of the water. So here we have an acid and a base, and we get water as a product, and we also have another product we refer to as a salt. And a salt can be defined as an ionic compound composed of a cation from a base and an anion from an acid. In this case, we have calcium 2 plus that comes from the base calcium hydroxide, and we have NO3 minus, the nitrate ion, that comes from the acid nitric acid. So we can write out a net ionic equation for this particular reaction, and we're going to use the same rules that we did from a previous section. So here we have 2H plus in aqueous solution plus 2 NO3 minus, also in aqueous solution, plus calcium 2 plus in aqueous solution, plus 2 OH minus in aqueous solution, giving us calcium 2 plus 2 NO3 minus plus 2 waters. And since water is a pure liquid, we're going to treat that just like we did a precipitate, and we're going to keep that together as the liquid here and not break it down like we do the ions. So in this particular reaction, we can now cancel out the spectator ions. So the nitrates are going to cancel out and the calciums are going to cancel out, and that gives us 2H plus 2 OH minus, giving us 2 waters. Typically when we write chemical reactions, we like to write it in its simplest form. Here we have a coefficient of 2 in front of each reactant and each product, so we can simplify this to say H plus in aqueous solution plus OH minus in aqueous solution is going to give us water. And this is the net ionic equation for a neutralization reaction that's going to occur between a strong acid and a strong base. So here's our neutralization reactions and how we can define them. Another type of reaction that we observe between acids and bases are ones that have formation of a gaseous product. And typically, when we see reactions where we have gas formation, it's going to be an acid plus some kind of salt, and that salt needs to contain a carbonate, which is CO3 2 minus, a sulfite, which is SO3 2 minus, or a sulfide, which is S2 minus. An example of some of these reactions would be Na2CO3, which is sodium carbonate plus 2 HCl, giving us 2 NaCl plus H2CO3. When we have this particular reaction, carbonic acid, which is H2CO3, is one of the products. This carbonic acid is going to break down or decompose, and carbonic acid will decompose into water plus CO2 as a gas. Okay, so the CO2 right here is our gaseous product. And when you react these acids with one of these salts, you're going to see a bunch of bubbling in the particular solution. So that's our evidence of the gas that's produced, and it's going to come from the decomposition of the carbonic acid. A similar thing happens if we analyze the sulfites. If we have sodium sulfite, which is Na2SO3 plus 2 HCl, giving us NaCl plus H2SO3. Our H2SO3 is also going to decompose, and it's going to decompose into water plus SO2. And SO2 in this case is going to be our gaseous product. The last example that I'll give is potassium sulfide, which is K2S, plus 2 equivalents of HCl, is going to give us 2 KCl plus H2S. And H2S, in this case, is going to be the gaseous product. And the evidence of this is that it smells like rotten eggs. So our gaseous products that are produced are H2S, SO2, and CO2. And again, there's usually some type of physical observation that you can see from these gaseous products. In the first two cases, you're going to probably see some vigorous bubbling in your solution. In the second case, that solution is just going to smell awful, like rotten eggs. So these are the types of reactions that we observe when we look at acids and bases and how we can combine them. Okay? So make sure you know what acids and bases are, know the strong acids and strong bases, and know how we define a salt. Then we can look at the properties and the reactions that take place when we add those two together.